Hey everybody, just two more lessons in our trig functions and graphs unit. Today we're looking at lesson 9 and also lesson 10. But first of all, let's talk about this new term that we're going to be using, sinusoidal functions. Okay, so a function whose graph represents a sine or a cosine curve, right, like this, is called a sinusoidal function. The graph of the sinusoidal function is called a sinusoidal graph, obviously. Okay, now many periodic phenomenon have sinusoidal graphs. For example, the time of a sunrise as a function of the day of the year. Okay, that keeps repeating or is periodic. The height of a chair of a Ferris wheel as a function of time, also periodic and sinusoidal. The depth of the ocean due to changing tides. Tides, again, very periodic as a function of time. So there we go. We're going to look at some of these examples of periodic functions or sinusoidal functions. So in this lesson, lesson 9, the equation of the sinusoidal function will be given. Next lesson, in lesson 10, you'll have to derive what the equation will be. So that's a little bit trickier. Most of our equations will be functions of time, meaning the variable on the right-hand side will be t, and the period, therefore, will be in time units. All right, we're going to be using the graphing calculator to solve some of these, and therefore, as a result, we have to determine a suitable window setting. Okay, otherwise we're not going to get the right graph. Okay, so let's take a look at an example of how we would do this in example 1. Okay, the depth d meters of a harbor, of water in a harbor, t hours after midnight. So let's take note of what the variables represent. So d is depth in meters. Okay, t hours after midnight can be approximated by the function d of t, yada, yada, yada. This equation is going to be important, where t is between 0 and 24. And again, that was hours, so that's like 24 hours. Okay, so basically 1 day. Determine the max and min depths of the harbor, water in the harbor. We're going to need this for doing our window settings later, but if you recall from the last unit, our maximum is found by going d plus the absolute value of a, and our minimum is going to be found by going d plus or d minus the absolute value of a. Okay, so let's try that. D. Okay, now this is kind of turned around, isn't it? Usually we see the cos function like this, and then the constant added afterwards. So let's turn that around so it looks more familiar to us. So our d value would be 12. Okay, that's our d. Our a value, the number in front of cosine, would be 5. So it would be d plus 5, which is 17, and d minus 5, which is going to be 7. And the units on that, d was in meters, so d as in depth was in meters. And there we go, our max and min depths of water. Okay, determine the period of the function. Okay, what do you remember about period? The length of one cycle, right? And also, if we have the equation, which we do, we can find the period by going 2 pi divided by our b value, if it's in radians. Can't really tell from this, but most often these application problems are in radians, so we'll stick with the 2 pi. Okay, so 2 pi divided by, what's b? B, the number in front of our independent variable, is 0.5. Okay, so we need to simplify this. 0.5 is like 1/2, right? So let's write that as 1/2. So we've got 2 pi divided by 1/2, which means multiplied by the reciprocal of 1/2, which means we're going to have 4 pi. There's our period. Okay, now part C, write a suitable window which can be used to display the graph of the function. Okay, so x and our y window settings. In this case, x is actually t and y is actually d, but on the calculator it'll be x and y. Okay, so time was to do with the period, right? So the length of one period here would be 4 pi. Okay, so we'd probably want to go from 0 to, now let's think about that. Do we want 1 cycle to show up or 2? Maybe 2. Let's go to 8 pi. And our tick marks could be every 2 pi, let's say. Okay, so x min, x max, and x scale. Okay, now depth, our lowest depth was 7 meters. So we could go with 7, but on a real life case, I usually want to go with 0, if at all possible. And then our highest is 17. I'd go a little bit bigger than that. Let's go 20 and make our tick marks every 5. All right, good. So then they ask, what is the depth of the water to the nearest tenth of a meter at 2 a.m.? Okay, so what is the depth of the water? They're asking for D, which means they must be giving us T. Okay, so at 2 a.m., and now remember, T was hours after midnight. Do you remember our definition up here? Hours after midnight. So at 2 a.m., that would be 2 hours after midnight. So given T, find D, we could actually just plug that into our equation then. 5 cos 0.5, here's our T value, 2, better put extra brackets around that, and then plus 12. Okay, so let's put that in the calculator. Now what mode should you be in? Should be radian mode, right? Because we use 2 pi over for our b value, or for our period. So make sure you're in radian mode, and we'll put that in the calculator. I'll do that as well, see if we get the same thing. Pause your video. Okay, so we'll put that in our graphing calculator, hit enter. Now if you're not getting 14.7 like I did, chances are you're probably in the wrong mode, you're in degree mode. Maybe you have a bracket issue, make sure both 0.5 and 2 are inside the brackets of cos. Okay, so we're getting 14.7. Our min and our max were 7 and 17, so that's seeming reasonable. And they want to the nearest tenth of a meter, so your answer would be 14.7 meters. Okay, now the next question, it says a ship requires a minimum of 8.5 meters to basically come into the harbor. So when they're giving you basically the y value, or in this case the d value, the depth, we actually are going to solve it by graphing it. So while we've got the calculator here, let's type in, now this time you want to have a variable, so it's going to be 5 cos 0.5 x, okay, and then end your bracket on your cos, and then plus 12. Okay, oops, got 2 instead of 12. Okay, you want to have a variable in here, so if you'd used a number like we did on the last example, you'd just get a horizontal line. Okay, so let's set our window settings to what we defined them earlier. So 0 to 8 pi. Okay, tick marks every 2 pi, although that doesn't really matter. Minimum 0, maximum 20, scale, oh, not 2, 5. Okay, good. And let's take a look at the graph. That looks pretty good. Now we want to know when the water is going to be below 8.5 meters because the ship won't be able to come in there. So what we're going to do is in Y2, we're going to put in 8.5. Okay, now take a look at that. Okay, so we can tell when there's a certain span of time here where it would be too low for the ship to come in. All right, so we should probably find that first intersection point by going second calc, intersect. Okay, they're asking which curves do we want to find the intersection of, and it says first curve. Take a look at your equation, that's our first curve. Then it jumps to the second curve, 8.5. Yes, that's all good. Now for guess, you want to move closer to where you think the intersection is that you want to find. So we're going to go over here, and there we go. Hit enter, and there's our intersection. So 4.69. Okay, it says by what time to the nearest minute. Okay, so that's another little quandary there, how we're going to find that, which I'm going to show you in a minute. So 4.6924, let's say. 4.6924 is basically our t value. Okay, and by what time to the nearest minute must it leave? Okay, so that would be, it's like that time, the 4, would be 4 a.m. Okay, now this part is a portion of an hour, right? So it's like 0.6924 of an hour. So what we're going to do is we're going to multiply that number by 60 to get it into minutes. So 60 minutes per hour gets rid of the hours. Okay, and then we'll know how many minutes. All right, so we'll bring up the calculator again to do that. And since we have that number, whenever you find an intersection like that, your calculator stores it in x. So if I quit out of here and I type in x and hit enter, look, there you go. So let's take away the 4 part. Okay, now we have what part of an hour multiplied by 60, and oop, that was by 6. I'll just multiply by 10 again. Okay, there we go. So 41.5. So if we round that up to the nearest minute, it would be 42 minutes. Okay, so 42 minutes. So what time must it leave? 4:42 a.m. Okay, good. I didn't write this one down from before. What was it? Let's bring up that calculator again. And let's see if I can bring that up by going second enter a few times. Did you guys know you could do that? Bring up things you typed in from before? There we go. That's the one I want. 14.7. Okay. So this answer would be 14.7 meters. Okay, good. We got all that. F. What is the next time to the nearest necessary minute? Necessary minute, that sounded weird. Okay, that a ship can return to the harbor. Oh, so that means we're going to have to find that second intersection point right here. So why don't you guys go ahead and do that. Remember, it says what time, so you're going to have to figure out the time just like we did on the last one. So go ahead, find that intersection point, pause your video, and then we'll check back and see if you got it right. Okay, so our x-coordinate of that intersection would have been 7.87398. Switching that to a time value, it would be 7:52 a.m. And if you can't remember how we did that, take a look at the previous question. Okay, let's look at the last example. Okay, example 2. In a certain town in Alberta, the time of sunrise for any day can be found using the formula T equals yada yada yada. Ooh, that looks ugly, doesn't it? Where T, that's the thing about real life things. They're not pretty, so if you try and turn real life stuff into an equation, it usually does look ugly. Okay, so where T is time in hours after midnight. So this time our dependent variable is time, okay, and that's hours after midnight. Okay. And then D is the day number, okay? So the day number of the year. Okay, write a suitable window. So I'm going to let you guys go ahead and do this, but remember how we did it last time. We looked at our period to determine our X window, and we looked at the max and the min to figure out our Y window, okay? So you guys go ahead and get the period, max, min, and see what we can get for some window settings, okay? Pause your video. Okay, so you might not have the same period as what I've determined here because you might not have caught that this 365 is basically underneath that 2 pi, right? Because normally we just see like the independent variable minus a number. So we had to throw that underneath there, making our b value 2 pi over 365. So to find our period, 2 pi divided by 2 pi over 365, giving us a period of 365. So window setting, 0 to 365, scale, who cares? Okay, max min, we go d plus a, and then d minus a to get these values, and we just want to set our window settings so we've got those showing up. Okay, so we should be able to graph this, and when you do, we're going to figure out to the nearest minute the sun rose. So we're looking for time, which is like our y value, okay, on the 127th day. So that's d, or x, would equal 127. I'm just going to write x equals 127. Okay, so why don't you graph that? See if you can figure that out from the graph. You can actually graph it and then just type in trace. I'll show you how that's done, so you get it in your calculator as well, okay? Pause your video. Okay, so we should have this graph showing up. If you don't, please check your equation. Make sure, pause the video if you want to check your equation. Make sure all the brackets are the same as mine. Make sure you're in radian mode and your window settings are what we did. So now to get when it was 127, you just type trace and then type in 127 for x, hit enter, and there's our y value, 4.9629, okay? 4.9629. And again, they want the nearest minute that the sun rose, and this is hours after midnight again. So the same way we determined time before, it would be 4 something a.m. So we need to change this part back into minutes. Oh, I was so hoping we would finish this within the time. So pause your video. No, never mind. We'll finish it up in part 2 of lesson 9. It'll be very brief, so we'll see you there.